This is Eric, a highly skilled college senior. However, Eric has a bad case of interview anxiety and fears he will not be able to land a job after graduation. To improve his interview skills, Eric consults a career counselor. After a 20-minute mock interview session, he receives suggestions to show more enthusiasm and confidence in his voice, maintain more eye contact with the interviewer, and smile more often. Eric understands the areas that need improvement and wishes to practice more. However, limited counselor availability and schedule conflicts make this difficult, and Eric does not want to ask his friends for help due to fear of social stigma. So, can we give people like Eric some kind of an intelligent system that enables them to practice their interaction in their own environment, practice as many times as they wish, and get feedback to improve their communication skills?
Building such a system requires a human-centered artificial intelligence approach. The system should behave like human, talk like human, look like human, and most importantly, think like human. In other words, we need to build a virtual agent that is able to understand what people talk about, capture people's expression, and interpret people's emotion, so that it can provide real-time response and effective feedback. The system should include two main components: the recognition module and the analysis and response feedback generation module. The recognition module identifies and collects vital data from the interviewee's verbal and nonverbal response to the interview questions. It tracks the interviewee's facial expressions, voice modulation, word usage, and several other data. The analysis module evaluates the recognition data to produce proper human-like response in real time, such as head movement, gaze, posture movements, etc. This creates a realistic atmosphere that closely mimics a real-world scenario. The collected data is also provided as feedback to evaluate and improve the communication skills. The researchers at MIT have developed MARC, which stands for My Automated Conversational Coach. MARC consists of a 3D capture which sees using a standard webcam, and it listens and responds in real time. As the person is interviewing, it will nod its head and will smile at the right moment to make it look like it is listening to you. And in the end, it can give you feedback on your nonverbal skills. For example, it can show you where in the interaction you smiled. It can keep track of your voice and modulation, show how well you modulate your voice. With more practice, you can track if you are really getting better or not. So all the details that you don't get to see are there in front of you.
The amazing performance of Mark system relies on its visual and conversational intelligence. Mark can recognize the facial expressions of the interviewee, especially the smiles. Also, it can track the head movement and detect nodding and shaking actions. With this information, the system tries to interpret the interviewee's emotion and attitude. In response to the interviewee's emotion, it performs facial and posture animation, such as changing the facial expression, moving the eyes and lips, and using hand gestures to act like a real human interviewer. It also provides feedback on the interviewee's nonverbal behavior after the interview. The implementation of this intelligence requires machine learning algorithms. For example, in facial expression recognition, the main idea is to classify the expressions into several patterns, like smiling or neutral. Mark uses AdBoost algorithm to boost the classifier. Given a training set and several weak learners, AdBoost algorithm can provide a strong learner that has a better classification. Suppose we are training some weak classifiers with a set of sample face images. In each iteration, for those examples that are misclassified, we increase their weights so the next classifier will pay more attention to them. Finally, the hypotheses from all these weak classifiers are merged into a new hypothesis that is more accurate.
Mark also exhibits conversational intelligence. This system talks like a human. It asks interview questions from a list of common interview questions and uses acknowledgements at the end of each answer. To analyze the interviewee response, the system performs prosody analysis and speech recognition. The system captures the interviewee's speech signal and automatically recognizes pauses, nodders, and pitch variation. Such information is extracted from speech signal using non-neural signal processing algorithms. At the end of the interview, the system gives feedback on the prosody. The other aspect of conversational intelligence is speech recognition. The system extracts words from the interviewee's speech signal according to the pause between them. It counts how many syllables there are and computes the speaking rate. For each word, the system determines whether it belongs to weak language by searching the word in the complete list of weak language dictionary. It provides the percentage of weak words used during the entire interaction. The interviewee can improve their communication skills by studying all the feedback.
Interpersonal skills are key to being successful at work and at home. How we express ourselves defines who we are. Though we just present a scenario in a job interview context, a system like Mach can help improve the communication skills in any context, such as helping people with public speaking, social phobia, dating, or people with conditions such as Asperger's syndrome who struggle with maintaining eye contact and responding to social cues.